بسم الله الرحمن الرحيم رب زدني علما.
So now the next two components we'll try to understand the ingress and egress proxy tunnel routers. Now we call it as a proxy tunnel routers. The previous one what we discussed was the tunnel routers, and now we'll try to understand the proxy tunnel routers. Now proxy tunnel routers play an important role in enabling the communication between the LISP sites. Let's say we have this LISP site here, and you are trying to communicate with any of the non-LISP sites. So the previous one, what we discussed was the communication between the LISP and LISP2 sites. But whereas here we have two different sites, one is a LISP enabled, and whereas the another site, which is not LISP enabled. So there are two specific components we use here: Proxy Ingress and the Egress tunnel routers. So these routers are responsible for encapsulation and the decapsulation of your packets, which is especially between LISP and the non-LISP within the same infrastructure, because you will have the networks which is built based on the IP, a normal IP network, as well as you have a LISP enabled network. So how we are going to communicate between them? So first, let's try to start with Ingress tunnel router, the proxy ITR, the proxy ingress router. Now this is going to receive the packets from any non-LISP sites, which means let's say we have a specific PC, the user is trying to send out a packet which is destined from 100.1.1.1, and that my destination is 200.1.1.1, which is on the LISP site. So now this is my endpoint. So the endpoint is going to send out a packet to the local router, and the local router is going to check the routing table based on the normal routing information, because it is not having any list, and it says that to reach out this 200.1.1.1, let's say the next hop is this one, 50.1.1.1. So to reach out, this is the next hop. So the packet is forwarded to this router. Now this router is the border router. Now this is the border router which is connecting between your non-LISP as well as the LISP network. So the proxy ingress router is going to receive the traffic from a non-LISP sites. Like in my case, this is my router. Let's say router 1. That's the name we give. And now this particular router is responsible for encapsulating the packet for a LISP enabled sites, because now it has to send out the traffic to this router, right? Of course, it has to do encapsulation. And the encapsulation process is the same thing. It is going to add the endpoint identifier. And to reach out this endpoint identifier, what is the ITR, or what is the router? And this routing locator address is going to be, let's say, 61.1.1. So 61.1.1. So it's going to get that information, the mapping information from the mapping server, and it's going to encapsulate the packet. Okay. So now this particular router is going to encapsulate this packet to LISP enabled sites. Okay. Like I said, the example here. Now this is your ingress proxy tunnel router. So now the example, as I said, here we have this scenario where the packet is generated from the remote branch office and it's being sent. So the packet is coming from a non-LISP and it's being sent to the destination on the LISP network. So there is an intermediate router or the border router, which is connecting to the non-LISP network, and that is going to encapsulate the packet and send it back to the remote router. Now, similar way, if you take the other way. So what is the ingress? A quick review: receives the packet from non-LISP site. That's what we discussed, coming from the non-LISP sites. And what is the job? It is going to encapsulate the packet to send the traffic to the LISP enabled sites, or it can natively forward to any non-LISP destinations. And that is typically a normal routing, we call it as. Now the other one, we have a proxy egress tunnel router. Now, the proxy egress router is responsible for decapsulating the packets. So decapsulating the packets from the LISP sites, and again, delivering to any non-LISP sites. So you can take it as a reverse direction. So it's like the same router, you can take it like this router. So we are sending the packet from here, let's say 200.1.1.1. is sending a packet to some network, which is 100.1.1.1. So this is your Lisp enabled network, and you're trying to send the packet to any non-Lisp one. Now, in this case, again, the packet reaches the gateway as a normal IP packet. And this router is going to identify that this is a kind of a destination. So to reach out that destination, this is the routing locator. And it reaches this particular router here. And now the job of this router is to send this packet to a non-Lisp network as an IP packet, which means it is going to decapsulate the Lisp encapsulation. So at the time of receiving, you can say the same router is doing the job of egress. So typically here you can see the same router is actually doing the roles, depends upon the direction, how you are sending the traffic. So as the traffic is moving from a Lisp network to any non-Lisp network, it is decapsulating the packet, which is typically doing this role of egress. And when the packet is coming from a non-Lisp network to Lisp network, it is doing the encapsulation, which is typically an ingress proxy router. So in simple words, we can say the proxy router, now the proxy is kind of an intermediate router, which is used to enable the communication process between the Lisp and the non-Lisp. So when the traffic is going from Lisp to non-Lisp, we call it as the egress. That is, decapsulation happens. And when the traffic is coming from non-Lisp to Lisp, Lisp encapsulation, that is going to be encapsulating the packet, which is an ingress. Okay, so this is a typical example. So in both the examples, the proxy ingress tunnel router and the proxy egress tunnel router, they're actually serving as an intermediate for providing a seamless communication between the non-Lisp network as well as the Lisp network. So this will ensure that the packets are correctly encapsulated and decapsulated for secure communication between both the networks. And we can have both the Lisp and the non-Lisp enabled networks can coexist in the same infrastructure